this module, you will learn about the general equation of a line and how to reduce it to its other forms. You are already familiar with first-degree equations in two variables. Here, a, b, and c are real constants such that both a and b are not equal to 0 simultaneously. The graph of an equation of this form is always a straight line. Thus, an equation of the form ax plus by plus c is equal to 0, where a, b, and c are real constants, and a and b are never equal to 0 simultaneously, is called the general equation of a line. You are already familiar with the slope-intercept form, intercept form, and normal form of the equation of a line. Now, let us see how we can reduce the general equation of a line into these forms of the equation. Let us start by reducing the general equation of a line into the slope-intercept form. Consider the general equation of a line such that the constant b is not equal to 0. Rearranging the terms in the general equation, we get by is equal to minus ax minus c. Dividing both the sides of the equation by b, we get y is equal to minus a upon b into x plus minus c upon b. Equation 1 is similar to the slope-intercept form of the equation of a line, where the slope m of the line is given by minus a upon b, and the y-intercept c is given by minus c upon b. Thus, equation 1 represents the slope-intercept form of the equation of a line, with slope equal to minus a upon b and y-intercept equal to minus c upon b. Let us see what happens if the constant b is equal to 0. If b is equal to 0, the general equation is reduced to x is equal to minus c upon a. This equation represents a vertical line with undefined slope and the x-intercept equal to minus c upon a. Now, let us reduce the general equation of a line into the intercept form of the equation of a line. Consider the general equation of a line such that the constant c is not equal to 0. Rearranging the terms in the general equation, we get ax plus by is equal to minus c. Dividing both the sides of the equation by minus c, we get a upon minus c into x plus b upon minus c into y is equal to 1. Rearranging the terms, we get x divided by minus c upon a plus y divided by minus c upon b is equal to 1. Equation 1 is similar to the intercept form of the equation of a line, where the x-intercept a is given by minus c upon a, and the y-intercept b is given by minus c upon b. Thus, equation 1 represents the intercept form of the equation of a line, where the x-intercept is minus c upon a and the y-intercept is minus c upon b. Let us see what happens if the constant c is equal to 0. If c is equal to 0, then the general equation is reduced to ax plus by is equal to 0. This equation represents a line passing through the origin, cutting no intercept on any axis. Let us now reduce the general equation into the normal form of the equation of a line. Consider the general equation of a line. Rearranging the terms in the general equation, we get ax plus by is equal to minus c. Equation 1 is similar to the normal form of the equation of a line. Equating the like terms in equation 1 and the normal form of equation of a line, we get equation 2. From equation 2, we get cos omega is equal to minus ap upon c, and sin omega is equal to minus bp upon c. Let's denote these two equations as equation 3. Substitute these values of sin omega and cos omega in the identity sin square omega plus cos square omega equal to 1. On simplifying, we get the value of p as plus or minus c upon under root a square plus b square. Substituting the value of p in equation 3, we get cos omega is equal to plus or minus a upon under root a square plus b square. And sin omega as plus or minus b upon under root a square plus b square. Substituting the values of cos omega, sin omega and p in the normal form of the equation of a line, we get the general equation of a line in normal form. Note that the constant term on the right-hand side of the equation is always positive, as it is the length of the perpendicular from the origin to the line.